Hello everyone, welcome to the video lecture series 1 of 8086 Assembler Directives. Generally, assembly languages are low-level languages for programming computers, microcontrollers, and other ICs. They implement a symbolic representation of the numeric machines, codes, and other constants needed to program a particular CPU. In general, it is said that the coder or the programmer has to remember the instruction sets which are given for the any particular processor or a controller. Generally, assembler supports directives to define data, to organize segment, to define macros as well as procedures. There are two types of statements. One is instructions and the other one is directives. The instructions are translated into the machine code, whereas the assembler directives are not translated into the machine codes. So this is the primary difference between an instruction set and an assembler directive. So now let us move deeper into the various type of assembler directives and its functionalities. So initially, we can say that the assembler directives are classified, or there are different types of assembler directives. Let us not jump detail into all the types of directives. Rather, we will see very few important directives. So moving into the first one, which is DB. Below DB, you can see the word DW, where DB means define a byte and DW means define a word. So as we all are familiar, byte is nothing but equal to 8 bits. So define a byte means an 8-bit will be allocated in the memory in order to define a data. So here you can see an example which is given, that is example sum db 0. Here sum is the user defined name, and when db is mentioned, that is define a byte is mentioned, you can clearly say that a 8-bit space will be allocated for the defined variable. So here the defined variable is 0, which means that 8 bits will be allocated for 0. Coming to the next word, which is nothing but define a word. Here, define a word will allocate 16 bits, and define double word, that is DD, will allocate, yes, it will allocate 32 bits. And coming to the quad word, will allocate 64 bits in the memory space, and DT, which is 10 bytes or the terabytes, will allocate 80 bits of memory space for the data allocation. So coming to the first assembler directives, it is DB, DW, DD, DQ, and DT. Yes, they are define a byte, define a word, define double word, and define a quad word, and define a 10 byte or terabyte. So moving to the next one is DW. As I have already explained, DW means 16-bit, and the 16-bit in hexa can be mentioned as 00002 FFFF, which is for an unsigned value. And if it becomes a positive value, it is 0002 7FFF and 8000 to FFFF for the negative value. So here there are few examples. You can see a list DW6512H, 0F251H, OCDE2H. I'm sorry, 0CDE2H. So all these are examples of defining a word where a list is the user defined name and DW is defined a word, which means 16-bit will be allocated. And when the numbers are given in a consecutive manner, it means that 6 consecutive memory allocations are reserved for the variable list, a list. Now moving to the next one, which is segment and end S. Here, any segment or the word which is mentioned as segment is used to indicate the beginning of a code, a data, or a stack segment. and end S is used to indicate that end of that particular code or data or the stack segment. So here you can see the general format of the segment, which is written as segnam, and that is ended as segnam ends. Here segnam, that is segname, is the user defined name of that particular segment, and segment indicates that the program or code or the stack segment is being started, and it is ended with the directive end S, meaning that that particular segment is completely ended. So before moving into the next directive, let me just wind up with what all we have seen. We have seen about the assembler directives. So what is a DB, what is DW, DD, DQ, and DT, and then the segment. So let us continue this assembler directives in the forthcoming lecture series. Thank you.